Hello everyone, hope you all are doing well. In this video, we'll discuss the last problem of Leetcode Weekly Contest 293. It's a hard level problem. The problem name is count integers and in intervals. So, given an empty set of intervals, we need to implement a data structure that can do two operations. The first operation is we can add an interval to the set of intervals, and we need to return the count of number of integers that are present in at least one interval. So that means that all the integers that are covered in the intervals that you have received till now, you need to return the count of those integers. So implement the count in the intervals class. We have a constructor which initially has no intervals. We have a couple of functions. The first function is add functions, which tells us that this is the interval that we want to add with left and right values. The left and right are inclusive. And the second function is count. So return the number of integers that are present in at least one interval. Note that an interval left comma right denotes all integers x, where x lies between left and right, being left and right being inclusive. So if we go to the example, so initially again, first the constructor is called, and then the interval 2 3 is added. Then again interval 7 10 is added. So, and when count is called, we see how many integers are there. So right now we have total of 6 integers. Those are 2 3 which are present in this interval, and the other 4 integers are 7 8 9 and 10. So total 6 integers are there. Then we add an interval 5 comma 8. So, and when count is called, we return 8 because we see there are some overlapping values. The only new values that are added are 5 and 6. 7 and 8 are already present. So total we have 8 distinct values. So we return that. If we look into the constraints, then left and right go up to 10 raised to the power 9, and at most 10 raised to the power 5 calls will be made to these two functions, and at least we'll have at least one call to count. So yeah, let's look how should we proceed in this type of problems. So this problem is similar to sort where we need to merge intervals. So like for example, uh, if suppose we have some intervals, suppose this is number line, and we have some intervals here, here, and so on. Suppose we receive an interval. Let's denote it by left comma right. So we need to check whether this interval is the interval that we have received till now is overlapping with any of the intervals or not. What could be the possibilities? First possibility is that the new interval is not overlapping with anyone. So that means it lies somewhat here, 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 here. These are the four positions, like for example, where it can lie. But the second possibility is that it can overlap with some of the intervals, something like this. It can overlap. So in this case, what we'll do, initially this was the interval. After that, we have received this interval. So the new interval, the merged interval, will be this. This will be the merged interval. If you can see, yeah, the highlighted one. So you merge this, and while we are doing the merge operation, we'll update the count of the number of integers that we have, because as soon as we receive an interval, we see whether it overlaps or not. If it doesn't overlap, we add the number of integers. That is, suppose this is low, this is high. So suppose r minus l. These will be the number of integers. Also plus one, because suppose uh, r is 3, left is 2. So how many integers are there? This is 2 comma 3. So that is why 3 minus 2 plus 1. Total we have 2 integers. We'll do this. If that is overlapping, if suppose this interval is however overlapping, what we'll do? We'll check the overlap. Suppose this was the interval with which it was overlapping. We'll check this interval, and we'll update the this interval with a merged interval. So the new interval will be, suppose this is left, this was right, this was right. Sorry, this is a start, this is end. So the new interval will be starting from left and ending at end. That is from here to here. This will be the interval, and also we'll keep on doing this thing until we find that the new interval has merged all the intervals that were possible to be merged. That means suppose it has merged this interval. Now the new interval comes out to be this one. right? Now suppose this interval is also being merged, like for example we have something like this, or uh, there is an interval which also needs to be merged, so the new interval will be something like this it will be something like this, yeah. Or one possibility would have been, like suppose there would have been interval like this, so what we would have done is that we would have merged this interval as well. So all we need to do is merge operations, so that we have one big interval, and while doing so we'll be updating the count. So let's look into the code of how we will proceed. So yeah, this is the code. We use a tree map because we want to keep the intervals in sorted format. So the key will be the start index, or the lower bound of an interval, and the value will be uh, the upper bound of an interval. So this is the tree map because we want it in sorted format, and we want to use functions which tell us that for the current interval what is the lower bound and the upper bound of the interval, so that we can merge it. This will be our answer. Now in the constructor we have instantiated it with a tree map, and when we come to the add function, the first thing will be that we'll check that whether if there is no overlap, we'll just add that. So how we'll check that? We'll check that there interval dot floor key comma right. That means the interval that we have received, if the end index of that doesn't have a lower bound, that means this is the first interval. Because what happens, suppose I have received an interval 2 comma 5, and I want to see whether there is an interval which starts from less than 5. If that is true, then we are good to go. Otherwise, if there is no interval which has a starting index of less than 5, that means this is the first interval. So in that case we'll be getting null. Now if we get an interval, suppose we get an interval 2 comma 5 was our range. Suppose we got an interval, and suppose that interval was 0 comma 1. Let's assume that was 0 comma 1. Now in that case we check what is the value, or what is the right index of that interval that we have got. Like for 0 comma 1, what was the interval that we got? 0 comma 1. Now we check what is the value for that interval, and now that is 1. Now that 1 is less than left. What is left here? Left is the lower bound starting index of the interval that we have received till now. So that is 2. The interval that we have received is 2 comma 5. We have tried to fetch the interval that is just less than it. The starting index is less than the lower bound of the right index, so that is 0 comma 1. Now 1 is less than 2, so that means there is no overlap. All we need to do is add this interval and update our count, and then we are good to go. Now if this is not the case, that means there is an overlap. Now we do some processing. We try to merge as many intervals as possible, if they are valid. So we take the start and end index. So start is left, end is right. These are the values that we have received. Now we need to do this thing, that remove overlapping intervals and update the count. So we run an infinite loop, and what we do is that we do the operation that we have done at the top. What we do, we check if there is an interval which has an starting index less than the current end. Then we fetch that interval. We fetch the upper bound of that interval, so that comes in L and R, left and right. And then what we do, we update our start and end index, because we want to update the left. Now we are constructing a new interval, right? We have some overlapping intervals, we received a new interval. Now we are trying to see what will be the new interval that will merge all these things. So the starting index of that new interval will be minimum of start and the interval that we have received just now after this call. And similarly the ending index will be the maximum of 2, maximum of the right index of these two intervals. Now while doing this, we also remove some integers, because the interval that we have received, it will have overlapping numbers. So that is why we remove this, and we remove the interval, because at the end we'll add the new interval. Now all we need to do, we need to break the loop until there is no overlapping with the interval start comma end. Now what we do, uh, we again do the same thing. We check whether there is a floor key having for the current end or not. If that is not present, or if the value for that floor key is less than the start, that means again now we don't have an overlapping interval. Now all we need to do is we need to break the loop. However, if there is an interval, this loop will be running uh, for more iterations. Finally, when we come out of the loop, we have the new start and end index of our merged interval, and then we finally add the integers in the current interval that we have. So at every particular point of time, whenever we are removing an interval, we are removing the elements that were present there, and whenever and at last when we add the new interval, we add the integers present in that particular interval. And when count is called, we just return this particular integer. So again, the basic concept here that we have used is we need to merge the intervals. We need to merge as many intervals as possible, first thing. The second thing is we are using a tree map so that we can find the lower bound and the upper bound of the current interval, so that that can be done in one time. So this is the logic that we use in this question. Hope you learned something new from this video. Please do support this video by giving up a thumbs up, do subscribe to the channel, and if you have any queries, do post it in the comments. I'll try to reach out to each and every one of you. Thank you.